If you always wanted to break things and generate stress around you to see how your application reacts under pressure, then this episode is for you. Welcome to Is It Observable? The main objective of Is It Observable is to provide tutorials on how to observe a given technology. Today's episode is part of the SRE series, where we already covered a couple of episodes. Introduction to SLI and SLO, what is chaos engineering, and we had a dedicated episode related to Litmus. Today, this episode will focus on explaining what is performance engineering. If you're looking for the content dedicated to performance engineering or load testing, I would clearly recommend to watch the YouTube channel called Performant. If you enjoyed today's content, don't forget to like and subscribe to the channel. So let's see what you're going to learn out of this episode. First, we'll introduce to what is performance engineering. Then we'll see the various types of performance tests. We'll look at the various performance activities, and we present few performance tools of the market. And last, we will do an interview with one of the DevRel of K6, Paul Balogh. Performance testing, or I would rephrase it in performance engineering, because the practice has clearly changed over the years since most of the organizations has implemented Agile or DevOps methodology. So what is the purpose of performance engineering? The main objective of performance engineering is to ensure that our system application is stable and performant. To guarantee, we will run various types of tests that will help us to validate certain situations that we may need to face in production. Each test that we are planning to run should cover specific risks or situation. For example, I'm in charge of a CRM platform. I may want to test a situation where I know that all the call centers connect to the systems at 8 a.m. on the morning. Clearly, everyone comes in the office, take a coffee, connects to the systems. So we will have obviously spike of connections in the system. So I would probably be interested to validate that our platform can handle the expected number of concurrent sessions that we observe usually at 8 a.m. Performance engineering means to be involved in the design of the architecture to identify performance and stability risks related to our application. And we also have to translate each risks into tests that would help us to validate and that we need to execute during our project lifecycle. We will need to build the right platform and automate to enable team in performance validations. Of course, the performance engineering cannot manage all the tests of our organization. Therefore, it will make sure to provide the tooling, the analysis process, because at the end, the objective is to offer a solution that will allow the team to run performance as a self-service. So let's see briefly the type of test that we could run to validate the performance of our system. There is the constant load. In this type of test, we want to run the average traffic against our application to validate the ability to handle the traffic. In this type of test, we will try to target specific throughput expressed usually in transaction per second or per hour. For example, I know that in production, I have on average around 200 searches per second. So I will need to configure and design my test to be aligned with this target. Unit performance testing. This usually is the first test that we usually run to measure the performance of one single user. Again, this test is important because if the response time is not acceptable with one user, well, it will be worse with more users for sure. Stress test. In this type of test, we are trying to stress our system. This is usually a technical test to measure the maximum throughput of our system. We have the ramp-up test. This test is not designed the same way as stress test because the stress test could generate high traffic with minimal think time. To remind you, think time is the time between two transactions. It's the time that the user takes to read or fill a form. The ramp-up test will help us to understand how our application scales, validate if our load balancer are properly working, and also if we have any elasticity mechanism, we try to validate if they are doing the right job. This test will ramp up user by steps. Each step will represent a percentage of our average traffic of production. Soak test. This test is designed to run a constant load during a long duration, 8, 24 hours, or even more. This test is there to validate that our application has no memory leak and no network connectivity issues during a long period. Performance used to be the last mile activity of our project because at the end we were waiting to get an application fully designed, tested, stable, and deployed on a represented environment. This approach does not make sense anymore today. Therefore, we implement the following approach where the complexity of our test depends on the environment. Our applications are today made of components, microservices, which means we don't have to wait until the UI is finalized to start testing anymore. Every component or microservices could be tested independently. So in dev, usually we are focused on testing and validating the robustness of our code through component level testing. So we test one single services or maybe two with constant load and we run the same test on and on. This test is there to fish for regression between two commits or two releases. Then, once we move to staging, we start to assemble several components together. So I would run tests that interacts with several components and validate that the network, the communication between the various components, is not introducing any performance issues. Remember, we are introducing distance between those services, potentially, so we can introduce also performance problems. In a staging environment, we start to have a more complex environment. So I would like probably to validate my load balancing policy by running stress test or soak test or ramp up tests. And then once we move closer to production, we should have a more represented environment. This is where we include all the end user constraints, like the network conditions of our users. We can test the load out of our cluster, out of the network of our organization, from the cloud, for example. And this is where we will combine tests that will help us to report the actual user experience from a browser or a mobile device. And it's also the perfect moment to combine load with chaos engineering to identify issues or introducing problems to measure how the system reacts. Like explained, performance engineering is all about simulating a load situation and measure how our system will behave, and also report the response time. The most important task in performance engineering is the ability to collect data to understand precisely, one, how our application behaves in a technical way. Then we want to understand the user context, the location of our user, the type of connection, when are they interacting, how frequent, how many concurrent users, and so on. We also need to understand what are the main user actions done by our end users in our production environment. The task of extracting data and understand the application and the user is very crucial because all the tests activities relies on its results. If you are extracting the wrong information, then you will spend time and energy to investigate, to build tests, run tests, analyze, investigate your issues, and optimize probably your systems based on observation that will never happen in production.
Oh, okay.
Knowing your application is one thing, but what is even more important is to make sure that our application has the right level of observability to allow you to test and have all the right details to investigate, drill down on the performance issue. That is why traces, metrics, logs, events, and even more are crucial to be efficient in analyzing our test results. Create your performance strategy. Once we know properly our application, our users, the main user action utilized by our end users, then we could start building our tests. By defining each test, we will define the user load, the various use case involved in the test, the think time of every transaction, the pacing, the number of transactions per second, the runtime time, the duration of the test, and the various SLO that will help us to determine the performance level of our system. Then start the fun game of designing the use case. We usually name this task as scripting. This task means translating the end user flow of our test into scripts that will reproduce the traffic of the end users. If your performance tool has a recorder, then the process will consist of recording the user flow. Then once we have the recorded scenario, we will need to correlate the scenario in order to make our scenario dynamic. Keep in mind that that correlation is the most important part, because we want to generate a realistic traffic and avoid just hitting the same page. Because at the end of the day, if we do so, we will just confirm that our caching system is working perfectly. In fact, I think we already know. To make it dynamic, we refer to functional data sets. So user, password, of course, product IDs or number, keyword to search. Then we have the dynamic variable extractors that would help us to create our scenario. Those extractors will basically extract information from the response of a given request, and we will store it into a variable. For example, if I may probably need to extract a product ID from the search page, I will extract that product ID and I will use it when I need to basically browse into the product, like HTTP domain name /product/ID. I will replace the ID by that variable. Collating means also designing a robust script that should handle functional exceptions. For example, if I'm not having the product page, I'm having an error page, then what should I do? Should I just restart the script, or should I do a process that clean up the session of the user? At the end, our script needs to be robust, because several hundred, thousands, millions of users will utilize that script. If you're generating extreme tests with more than 100K users, then you will also need to optimize all your variable extractors, because at the end, those extractors usually rely on XPath, JSON path, and of course regular expression. That at the end consumes lots of memory on our performance tooling. Once the scripting task is finished, make sure to test the script properly with several types of datasets. We want to remove all the errors that are related to our script. Dataset. The other important task is generating a dataset for your test. This is often the most complicated task of our process, because it's usually delivered by someone else who doesn't understand what we expect. Remember, we need volume, and dataset needs to be representative. For example, if you have login and password users, let's say, if all your testing datasets is user 1 to user 2, user 3, and user n, then the request that we send to the database will be slightly different in terms of behavior compared to our production. We will probably not utilize properly the index that are being designed for database, and as a consequence, we will discover slow queries. But in real life, our user, most of the time, their login user starts from A to Z. So the dataset is more representative, and the usage of the database index will be much more efficient. If you don't have enough dataset, you will face issues only related to your limited dataset. With limited datasets, you will have several virtual users using the same data. Therefore, you can run into deadlock situation in your database. So you will discover potential problems that in fact are only related to your dataset. Observability. Validate that you have the right level of observability with the right level of granularity and sampling. If you're collecting one data point every 30 seconds or minutes, then you won't be able to understand your issues because the average data that you collect will hide your issue. Production observability and testing observability is not designed the same way. In testing, we are fishing for issues, so we need as much data as possible. While in production, we need the right level and of details with the right cost. So less granularity in production will help us to operate our production environment. Analyzing communicate. Each test that is considered to be in error will require you to analyze, to understand the root cause of your issue. Which layer? Which component? Is it a configuration issue? Can we resolve this issue by changing the architecture design? Maybe adding some cache or more replica. Once we have run and executed all our tests and that we are confident on the behavior of our application, we can define a baseline. The baseline is required if you want to start automating your test. To automate your test, you will compare the generated results against your baseline or your reference test. With the help of a set of SLO, we could create complex validation rules that will cover performance topics, availability topics, stability topics, cost topics, and way more. Each SLO should give points. Then we could simply create one SLA per test based on a score. Similar to chaos engineering, performance engineering requires tools that will help us to simulate our expected traffic. So we have many commercial tools like Microfocus with Load Runner, great tool that could do lots of things to provide HTTP to enterprise applications. There is Tricentis NeoLoad, that is a modern enterprise load testing platform providing all the features that you expect of a performance engineering solution to support enterprise protocols such as SAP Citrix and also traditional HTTP protocols. There is Load Ninja for SmartBear, and we have Eggplant Performance. Then you have the open source solutions. So we have the Jmeter, the most popular open source solution. Several platforms today provide a SaaS offering around Jmeter. So we have Octoperf, for example, Blazemeter, we have Tricentis Flood, and more. Gatling is designed to run component level testing. Gatling is a dev-friendly performance solution that requires to code your test in Scala. We have Locust, and we have K6 from Grafana Lab. From the tool listed above, one tool is providing lots of features related to observability. It's K6. I will, by the way, produce dedicated episodes going deep on the K6 solution. But I think the best way of getting news ready to K6 is to call Paul Balogh, DevRel from K6 Grafana Labs. Hi Paul, how are you?
Hello, I'm doing well, thank you. Happy to be here. Happy you picked K6 to look into.
It makes sense. I just explained briefly what is performance engineering. Of course, it deserves more time and content, but there are dedicated channels that covers perfectly the performance engineering topic. I also briefly shared a list of performance engineering solutions available on the market, presenting commercial tools and open source solutions. I'm calling you because I would like to get news and product updates related to K6. Just to remind to the community, K6 has been recently acquired a few months back by Grafana. There are probably product updates or a shift in the strategy since this acquisition. Before we jump into the interview, could you briefly introduce yourself?
Sure. Yeah, as you said, my name is Paul Balogh. I've been a developer advocate now with K6 for just about 3 months now. So I'm still kind of a rookie, still learning things, but I'm primarily focusing on the extensions ecosystem. So I'm trying to work with open source developers to kind of build our community and, see what we can build with K6 and create all kinds of cool stuff. But yeah, in past lives, I've been primarily a Java developer. We just won't talk about that. And for about a little over 20 years. So yeah, so I've been primarily a developer, but now I've switched over into this advocacy role. So
behind all solution, there is always a story. Do you know why K6 has been built? What is the story behind the project?
It is kind of funny because, during my onboarding process, we have these pages where, we can learn all about the history of the company. And actually, K6 started as it was a MMO, a massively multiple online game. I don't know. I can't even remember what the acronym is for, but it started off as a game company back in like 1998, I think. And then, but they went on for 10 years. And then when, I don't know, they came into rough times, and then they had all this experience and exposure with having, large networking application and being able to, really squeeze performance out of the applications, that they started using that to do kind of a consulting service. And then from that, they changed into what became load impact. And then they started creating this as a software as a service. And then, about 2017, I think they rewrote the application using Go. I mean, previously they were using things like C and Lua and all that, but 2017 is when they decided to open source and then go with Go, and then with JavaScript for the scripting aspect of it. And yeah, then I guess about 1 year ago, then Grafana acquired K6 to go along with the whole observability platform. So it's kind of an interesting thing, but that's why you'll see on our on all of our swag, we usually have this crocodile, and that's because the original company, it was called Gator Hole. So, and the owner, the founders actually had a couple alligators at the office. So therefore we have Ed, and I think it's Ed and Bert are our mascots. So that's why you'll see on K6 we have all these crocodiles.
I was convinced that K6 was related to the mountains, so that one of the founder was an extreme climber.
One of the thoughts for naming it was Capablo, I think, which is Esperanto for capability. And so they did the Kubernetes trick, and so Capablo is K and 6 letters, so therefore K6. And then it just so happens there's the mountain in what I guess in Nepal that is, the K6 mountain. So therefore we have the mountain. So it's strange how things evolve. So
since the acquisition of K6 by Grafana, I guess that the product roadmap has been changed or prioritized to the Grafana stack. Could you share a bit the product updates, news? What is the medium-term strategy for K6? Is there any tactical feature that you want to bring on the market to grow your install base of users?
Yeah, sure. Yeah, that's always one of the concerns whenever any company is absorbed by another. But you know, with Grafana Labs and K6 really mesh nicely because they were both focused on the open source aspect. Yes, there are paid for cloud services, but the focus is really still on the open source. So that's where the two companies really did mesh together, and you know, wanting to be open, you know, completely open. You know, the big tent philosophy is what Grafana touts, and so yeah, it was a perfect blend, and then we fit well with the overall observability platforms that Grafana provides between all the different products that they have. So this is just on the load testing piece of things, but so obviously, though, that is bringing about some changes with our product roadmap in that, you know, in the past we have different outputs that K6 can generate metrics for, publish them to. But with the extensions, we can have very different outputs. Well, one of the focuses, what we'll probably end up doing is that now Prometheus will become the prime, you know, output for the metrics. You know, Prometheus being that open source project. And again, that's one where Grafana is one of the major contributors to. And now with our Mimir product, which is a highly available, massively distributed, you know, metrics database that is built on Prometheus, will probably change that to be the default output.
That sounds relevant because I have been looking at K6 repo. There are plenty of extensions, output extensions. You can generate outputs in JSON files and also push data to Prometheus. There is also, by the way, a Datadog extension. I also looked at the Grafana repo and I discovered several projects built by K6. For example, there's a project that helps your internal team to test Loki with the help of the Loki client, or sort of client generator for Loki. I guess K6 is also helping the entire Grafana stack to test and benchmark the various solution of Grafana Labs.
Yeah, I mean, so yeah, besides the Loki one, you know, for the big product release that we had recently of being Mimir with, you know, it's touted as, what is it? I think over 1 billion metric readings per tenant in this time series database. Well, yeah, there's a custom extension that was created for testing Mimir.
Is it the client remote?
Yes.
Okay, the client Prometheus. I was wondering what was the use case between the client Prometheus plugin.
It is a little confusing because, yeah, we do have the two. There's the client Prometheus, and then there's also the remote write, which is that's the normal one, I guess, where you would say, okay, I want to actually just output my metrics to a Prometheus server, whereas the client one that's actually for load testing Mimir itself.
In terms of core protocol of K6, there is currently HTTP, gRPC, WebSocket, and I don't know if it's official, but there is also extensions like the browser-based extension and many others like MQTT, IMQP, and many others. Are there a plan to extend the protocol support by adding new clients or protocols?
Well, that's one of the things where we really look to the community. I mean, because right now with the extension ecosystem, it's the sky's the limit, as they say. I mean, it's, you know, it provides the hook so that, yeah, anybody can go ahead and create for any new protocol that comes up. They can create an extension, and, you know, ultimately we're trying to keep the actual K6 binary itself lean and mean. So we don't, that's why we have this whole compilation step where you just, you know, if you want special functionality to be, you know, executed from the JavaScript, you just compile it in. So just like in the old days when, you know, everybody's compiling their own Nginx binary because, you know, they want special routing rules or something, but yeah, so it's that type of a framework. So yeah, sky's the limit. Any protocol that comes up, we'll be able to do something with it.
One plugin that I have been using a lot when testing and working on OpenTelemetry is the XK6 distributed traces. I think it's amazing. I'm wondering if K6 is not even the only load testing solution of the market providing this feature, where load testing solution is basically creating the first span when it's generates the load. I was surprised that this extension has not been promoted more because it's super useful.
Yeah, no, and there are, there's work going on with that. I mean, so one of our developers on the, he's on the SRE team, but he likes to work on some of these extensions. He's been working on that, and he's actually one of the committers or maintainers for Tempo.
And the second extension that I really like, and I will share the value soon, is the K6 operator. It's great to have an operator and also the specific CRD K6 that help us to define your tests and be able to run those tests in a distributed way within your cluster. I was wondering if your SaaS-based solution of K6 was basically based on the K6 operator.
So right now it's not actually the backing part of that, because originally the open source version was non-distributed. As far as you can do distributed tests, that was on the enterprise software as a service version where you could do that. But now with K6 operator, yes, anybody can go in and deploy into their own Kubernetes environment and then run that. But I'll let the cat out of the bag that our actual backend service right now is not Kubernetes based.
You mentioned a lot about the community, and it's great to rely on the community to extend the capacity of the tool. Could you remind the community how they can start contributing to the K6 project?
It's really easy. We have a very low barrier to entry. We want to welcome everyone and just come on board and learn. We all learn this stuff together and build it out. But just come out to GitHub and Grafana. I mean, unfortunately, there's like 700 different repositories there, but just do a search for XK6 - and then you'll find all kinds of different plugins there. Or I'm sorry, I shouldn't say plugin, I should say extensions. And then, just pick the one that, pick the flavor that you're looking for. Again, like I said, we have a very low barrier of entry. We do have, we just asked that folks sign a CLA because we do want to keep this all open source, and then freely available. That's very big for K6 as well as Grafana. So it's just jump on that. We have obviously the typical forums, and we have a community forum. Is community.k6.io, and I hope I have that right. And then we also have a community Slack, but we typically funnel people more towards the community forums.
Thanks, Paul, for your time. You have answered to all of my questions. Wonderful solution. Let's hope that the community adds more features and extend the capacity of K6. And I really like the approach of providing a solution that generates the load and all the connection to expose the data in our observability platform, our choice. The user can then use the best of breed solution to analyze the results. See you soon. And if you want to learn more about Paul, check the social networks because Paul is pretty active. Thanks, Paul. See you. Bye.
Thank you.
That's it for today's episode related on what is performance engineering. This was a very compressed content. There is lots of dedicated content going on each activities in detail. So I would recommend, if you want to learn more, to check out to Perf podcasts. There's plenty of episodes related to that topic. If you enjoyed today's content, don't forget to like and subscribe to the channel. So see you soon for another episode. Bye.